I'm Karen, and now I'm going to explain assignment 2, design task 1, design a sequential circuit. So these are the conditions for the sequential circuit. So in this sequential circuit, there are two types of flip-flops are used. One is D flip-flops and another two is JK flip-flops. So JK flip-flops are triggered by negative clock edge, while D flip-flops are triggered by positive clock edge. So in order to have these two flip-flops triggered at the same time, the clock signal for one of them will be wired to an inverter so that the clock edge will be inverted. So for example, when JK flip-flop is triggered by negative clock edge, after the inverter, it will also be triggered by, because it is inverted, so it will become a positive clock edge. So after run the simulation, this is the output. So this is the C, B, A, and also the clock signal. So the clock signal wired to the scope here is actually the signal for the JK flip-flop. So I will refer to the negative clock edge. So to simplify, this is the changes of these three sets. Initially, they are 0, 0, 0, and next will be 1, 1, 0, 1, 0, 1, and after that, they will just repeat 0, 0, 0, 1, 1, 0, and 1, 0, 1. So to be simplified, this is the step sequence for this sequential circuit. And next, this is the table. I've completed it, and the result of this table is actually aligned with the Simulink result. The first step will be 0, 0, 0, and the next step will be 1, 1, 0, 1, 1, 0. Then the next one should be 1, 0, 1. 1, 1, 0 have a next step of 1, 0, 1, and then it will back to 0, 0, 0. So the next question, to force the flip-flops to a particular value by changing Ka or Kb setting. So in this case, I change both Ka and Kb to 0 because according to this table, the first case is if the J input is 0 and K is 0, then the flip-flop will hold its stats. And another case is if the current set is 1 and the K is 0, so no matter what the J input is, it will also remain the same, which is 1. So in this case, I change the Ka and Kb both to 0, and then I run the simulation, and I can get this result. So initially they are 0, 0, 0, then it will change to 1, 1, 0, then it will stop at 1, 1, 1. So to be simplified, this is the set sequence 0, 0, 0, 1, 1, 0, and it will 1, 1, 0. The next set of 1, 1, 0 is still the 1, 1, 1. The next set of 1, 1, 0 is 1, 1, 1, and the next set of 1, 1, 1 is still 1, 1, 1. So it will be forced to the same state. Yeah. So that's all for design task 1. Next, design task 2 part 1. It is to implement a decoder to decode the traffic light signal. So 0, 0 will be will turn on the red light, 0, 1 will turn on the green light, 1, 0 will turn on the amber light, and 1, 1 will turn on the pet light and also the green light at the same time. So this is the simulation. So 00 will turn on the red light, 01 will turn on the amber light, 10 will turn on the green light, and 11 will turn on the pet green light and the green light at the same time. So this is the traffic light, the vertical traffic light, and this is the horizontal traffic light. So the decoder subsystem used for the vertical and horizontal is actually the same. So this is the decoder subsystem. So from these two inputs, it will generate 4 outputs. So 00 will turn on the red light only. So the output here will be 1000, and 01 will turn on the amber only. So it will be 0010, and 10 will turn on the green light. So it will be 0100, and for the pet green light, the input should be 11. And to turn on the pet green light and the green light at the same time, so I add a OR gate at here, so they will be turned on at the same time. If pet green light is 1, then green light will be also turned on. So that's it for part 1. Part 2 is a traffic controller. So this traffic controller is actually to generate the signals green, flash, and P green as the inputs for the light controller in exercise 4. So this is the simulating block diagram. So it will receive 3 inputs for the traffic controller, which is the tram button, pedestrian button, and the car button. And this is the light controller from exercise 4. And these two are the decoder system from design task 2 part 1. So for the light controller, it is actually from the exercise 4. So initially, the green light will be turned on, and if there are signals, like if their train is coming, so the signal will be flashed, and it will enter this state, and it will automatically toggle between red and amber with 10 Hz frequency. So 10 Hz frequency means that it will have a period of 1/10, which is 0.1 seconds. So if the flash equals 1, so it will automatically toggle. So if the flash is not 1, so it will check if the P green is equals to 1. If the P green is equals to 1, the pet green light will be turned on, and also the green light. And if this it is not flashing, or the P green light is not turned on, the green light will be turned on for the car. And this is a traffic controller. So it is also a step machine. So based on the 3 inputs, it will decide based on their priority. So initially, this is the default state. So the traffic light will turn the green light. So for the first priority, it will check if the train button is equals to 1. It will enter this state, and this state will produce a flash signal. Flash equals to 1, while other will be 0. And it will repeat it if the train is still passing. And the second priority is the pet green light. If the pet button is on, it will produce P green equals to 1. So it will turn the pedestrian green light. And lastly, For example, for this flash, if the train is passing, after the train is passing, train button is equal to 0, and it will check if the pedestrian button is 1, then it will enter this state, and if it is not, it will back to the green light. Same applies at the pedestrian green light. So for the simulation, I need to wait for a while. Okay, alright. So now the car button is on, so it will display the green light. And if the pedestrian button is on, even if the car button is on, the pedestrian green light will be turned on. And this is the train button. If train button is on, it will toggle at 10 Hz frequency. And after this is off, and now because the pedestrian button is on, it will still turn light the pedestrian button. And if it is on, it will back to the green light. And same things applies if the train button is on, and if the pedestrian button is not on, and after the train finish passing, it will back to the green light. So that's it for design task 2. Part 3 is to implement a memory function for the pedestrian button, so it can remember when the button is pressed. And now I run the simulation, and now the green light is on. So now if I click the pedestrian button, the pedestrian green light will be turned on for 15 seconds. And for this button, I implement it as a momentary input. So once it is clicked, you can see a 1, input 1 here, and for the next second, it will change back to 0. And now you can see that after 15 seconds, the pedestrian green light will be off. Means that the memory is reset. And now I simulate another scenario. So within these 15 seconds, if a train is passing, and it will automatically flashing the red and amber light because the train has the highest priority. And now if the train has already passed, and it will also automatically reset the pedestrian button memory. And now another scenario, when the train is passing and there is a person, he pressed the pedestrian button, and the state machine is actually is able to remember that. And so after the train is passing, the traffic controller is able to reserve a pedestrian green light for him. And that's it for the simulation. And this is the state machine. So initially, it will enter the state, the button is not pressed, and only if the pedestrian button is pressed, it will enter this set, the button is pressed. And only when the pedestrian green light has on, it will enter another state. And for this state, it would check if the traffic signal is stopped. For example, a train is passing and the pedestrian green light has to be turned off, so it will automatically reset the memory. And another case is the pedestrian green light has on for 15 seconds, so it will also automatically back to the state to reset the memory. So in this case, the pedestrian green light, the input of the pedestrian green light is from the decoder system here. And so because this is a feedback loop path, so this state machine in the setting is changed to a more machine. That's all for part 3. design task 3 is to design a simple two-way traffic light control system at this junction. So this is Jalan Cawan. So the vehicles at Jalan Cawan will wish to turn right. And this is the main road, Jalan Tun Razak. So the vehicles at this road will wish to go straight. And in this case, induction sensor are used to detect the vehicle position. So the sensor might be installed at somewhere here. So for example, if there is vehicles passing through the sensor will be triggered, and the traffic controller will know that there is vehicles which to turn right. And also for this main road, induction sensor is also be installed. So this is the Simulink block diagram. So initially, this is both of them are 0. So initially, the traffic light for Jalan Tun Razak will be green. And now, for example, there's a vehicles passing through Jalan Cawan and wish to turn right. So the traffic light will turn red and green. In this case, there is no vehicles at Jalan Tun Razak. And now, if I have vehicles at Jalan Tun Razak and no vehicles at Jalan Cawan, so it will back to go straight. And you can notice that between both red light, they are holding at about 3 seconds. This is just for safety purpose. So there is another case if both Jalan Tun Razak and Jalan Cawan have vehicles to passing through. So actually, the traffic light will take turn to on the green light. It is I set the time interval to around 10 seconds. So now the Jalan Cawan turn back to red, and now Jalan Tun Razak turn back to green. So let's wait for another 10 seconds, and you can see the changes. Yeah. And now it is hold for 3 seconds. So that's all for the simulation. So now I'm going to explain more about it. So this is the decoder system. It is similar to the previous design task. It's just that there is no pedestrian green light for this case. I just have 3 cases only: 0, 1, 1, 0, and 0, 1, 0, 0, 0, 1, and 1, 0. So if there's an error to have an input 1, 1, then 3 of them will be turned off lah. And this is the traffic controller, and the right sensor and straight sensors represent the induction sensor put at the right sensor is for the Jalan Cawan, while straight sensor is for the Jalan Tun Razak. So initially, the green light for Jalan Tun Razak will be on. So if the sensor at Jalan Cawan is triggered, meaning there are vehicles which to turn right, so it will change to amber and then red with a gap of 3 seconds, around 3 seconds, then it will change to green for Jalan Cawan. So similarly, if there is no vehicles at Jalan Cawan now, and there is vehicles at Jalan Tun Razak which wish to go straight, so it will slowly change to amber, red, and then back to green. And in the case of both roads have vehicles, so actually they will take turn to turn on the green light. So if both of them are triggered, so they will take turn like around 10 seconds. They will have green light for 10 seconds, then it will change to amber, red, and let another traffic light to have green and also 10 seconds, and back to amber, red, and repeated. Yeah. So that's all for this simple traffic light control system. Thank you.